make up your mind, what are my expectations, right? In terms of infrastructure, this could mean when I run my Puppet manifests, right? I would like a user foo to exist on that system. I would like a process to run. I would like a service to be enabled, right? I would like a folder to exist. I would like an entry in a config file to exist, right? And each of those things would be one iteration of this cycle, working in small increments, okay? So you write a failing test, and this is also important because essentially your test framework could fool you. It could tell you it's green, although there is no implementation. So write the test first, run it, make sure it's red, and then you make the test pass. It means make the implementation, make the test green, and then clean up your code and make it better. It means refactor it, okay? Make it readable, make it worthwhile, make it understandable, okay? And what that helps you, what you end up with if you apply that to infrastructure, is first of all, of course, you are able to work with small increments. You'll end up with designed and tested code, and it's proven fact in software engineering that when you make up your mind how your users will use an API, or what your expectations are of the code when it's executed, you end up with a much better API design. Because you think much more about what your users are expecting from your system. Okay? It makes it more modular as well. Right? Because to make it testable, it needs to be modular. Right? It protects you against regression. So what I had is I started with Chef, then Puppet, and then Enhancement. And I wanted to get to a certain point where one of these tools are actually usable for a customer. Right? So when I then turned to another tool, I figured that now I could do this particular part better in the first solution as well, right? So I needed to do refactoring, and my tests, they helped me to show me whether this stays green, right? Whether my expectations still hold, right? If I made a mistake and if I broke my systems, my tests immediately told me, okay? And this also allows you, because you work in small increments, you check into your code base, that you are always able to return to a known working code, right? Should you ever end up in a situation where you don't know how to solve this particular problem in Puppet, right? And it maybe takes you 1 or 2 weeks to find out, you could always return to a known base, because you checked it in, and you know because you apply certain practices, so you test your code before you check it in. So you always end up with working and deployable, or with working infrastructure code in your code base. Right? And this is, if you look at that, in software engineering they say it's like an engine, right? Which always keeps spinning. So you write a failing test, you do the implementation, and then you make sure it's beautiful, it's appealing, it's documented, if it's not self-documenting, it's modular, and then you iterate it and you do the next feature, right? So coming to Test Kitchen. Test Kitchen is the executor is actually the test framework that you could use, okay? And I would like to talk about the key concepts. The cool thing is that all the key concepts that I would like to present are in a pluggable architecture. That means everything you see here can be extended with your own functionality. If it doesn't support a cloud provider that your company is trying to deploy to, you can write a plugin for it. If you're working with a new provisioning tool, if it's on Puppet in the future, who knows? Maybe someone already wrote a plugin for that new tool. Right? So let's have a look at it. So the key concepts are drivers, platforms, provisioners, and test suites. And I'd like to start with the drivers. So the drivers, they let you run your code on various cloud providers, for example. The list is quite extensive, I would say. All the important ones are there. And virtualization technologies like Vagrant, Docker, or plain old LXC. Platforms. They are the operating system that you would like your deployments or infrastructure to build upon, right? So this could be Linux or Windows based, and we're now with Test Kitchen version 1.4.2. Since Test Kitchen 1.4, you could also deploy to Windows. So Windows doesn't have SSH built in. It has its own mechanism called Windows Remote. And in order to deploy to Windows machines, there was an extension needed for Test Kitchen, which is now there since a few weeks actually. Now, the interesting thing is if you say, I want to test my deployments or my infrastructure things on a Debian-based platform, maybe Debian 8.1 or CentOS 6.5, how would you specify that? The cool thing is, Test Kitchen knows a couple of naming conventions. You just need to say, the name of my operating systems is CentOS 6.5, Debian 8.1, SUSE, whatever. And by a naming convention, it will actually, depending on whether you choose Docker or Vagrant, go to either Docker Hub or go to vagrantbox.es and download ready-made images for you and cache them on your disk, right? So you don't need to care about where do I get my images from to test, right? But you can always build your own ones and define them in the configuration of Test Kitchen. Okay, the next concept is provisioners. And they are the tools used to converge the environment. And as you may imagine, those are Ansible, Chef, Puppet, SaltStack, CF Engine. Those are currently supported. And why is that cool, especially for me, is because I needed a solution which supports at least 3 of them, right? Now, in the test suite, you define the tests which you would like to run after your environment has converged, after Puppet has run. You want to run your tests, right? You define the test suites and you define your test harness. A test suite would be, I want to have Java installed, and then I want my manifest to run. And then you run the test upon them. The expectations. The test frameworks currently supported, they are good old Bash, which is a bit, not the most convenient solution of these. But there's also Byte, which is a Bash-like syntax for testing. And then there is Ruby frameworks, Cucumber, RSpec, and ServerSpec. Do you know any of these? Okay, Bash, of course. Good one.
I've heard of Cucumber before.
Okay. How did you like it?
I like that it sounded like English, so when we write tests, it's very natural language.
But it can easily become a hassle if you do the implementation in the background, right? Because you have to translate that to an executable code, right? But I like it as well. Did you have the chance to get Cucumber in front of your business people so that they can read the acceptance criteria? Was it a use case in your company?
No.
Okay. Good. Do you have any questions so far regarding those key concepts? Because now I'd like to continue with the installation and I could actually use it. Okay. So what does an installation look like? You need a couple of gems. So Test Kitchen is implemented in Ruby. You can either in Ruby use a gem file where you provide, I need those and those gems, and then just execute the gem file, which installs all the dependencies, or just do a gem install on the command line. And the packages which you need are Test Kitchen. If you want to test inside Docker, you will need Kitchen Docker and Kitchen Puppet for Puppet. And then you can test on the command line using Kitchen version whether it's ready. So what does the configuration look like? So if you want to test a Puppet module or the manifest inside the module, you probably start with creating Puppet module, and then you initialize Test Kitchen. And there's a kitchen init command, which allows you to say through a couple of command line arguments, I would like the driver Docker to be used. Could also be AWS or Vagrant. And I would like the provisioner Puppet apply to be used. There's also a provisioner called Puppet agent. But if you use the Puppet agent, it requires you to provide a Puppet master on a different server. Right? And you then need to configure the agent, of course, for testing purpose to connect to that master. And what it will do is it will create a couple of files, and the most important ones are a kitchen.yaml file, which is your configuration file. And it will also create a directory called test integration default. And I will come to that in a minute what this actually means, right? Your tests will go here, that's what it is for. So when you look at kitchen.yaml after you invoked kitchen init, so this is what it looks like by default when you chose Docker and Puppet apply, is it will name Docker as a driver. It will use Puppet Apply as the provisioner, and it will give you two platforms by default. That's Ubuntu 14.04 and CentOS. Okay? And this one is interesting because actually a run list and the attributes are relicts from the days where Test Kitchen was only used by Chef or for testing Chef recipes. So this is something that you will want to override, and this is what I'm showing on the next slide. And this is what I meant by the conventions. Test Kitchen, if you use Docker or Vagrant, will automatically fetch images. And for example, that's also a cool feature. If there is no Ubuntu 14.04, but just, let's say a 14, this is maybe a bad example because there is no 14. But then it will be so smart and to get the closest number, closest version for you, and not quit with an error. Okay. Okay, now this is what it could look like, a simple enhancement. So I grayed out the ones which we already talked about, and the black ones are the enhancements. So you could provide a particular Puppet version if you want to run in your company with a particular version. This is where you can specify it. You can specify a files path, which has unfortunately no default value, which would make sense to point to files, but it's not in the implementation. You also would specify a manifests path, which you remember the path before. It's test integration default, is a directory which is created by Test Kitchen. But the Puppet Apply provisioner doesn't really know about this directory. It's a convention, but in this case, the Puppet Apply provisioner wants you to be explicit. Okay, that's why I defined it here. This is a manifest path, and here under test integration we have our test suites. And for the sake of this tutorial, we are perfectly fine with a simple default test suite. Okay, and the manifest which will be executed for that test suite is init.pp. Okay. You can provide verbosity flags and also debug flags to Puppet, which will be piped through. And then I cleaned up the part which was the chef relic, which I mentioned, for the sake of Puppet. Okay, now we've now defined our configuration, and what we can do now on the command line is to execute kitchen list. And kitchen list will take your configuration and combine the test suites which you define with your platforms. Okay. So you end up with an instance name default Ubuntu 14 and default CentOS 7.1. This also means if you have more test suites, for example, install user, provide service, then those platforms you would have those combinations listed in the instances column. So you would have a duplication of all the test suites with all the platforms that you run on. Okay. The driver is Docker, Puppet applies, the provisioner. We use SSH as transport. You could use different transport layers as well. And the last action here means what's the status of my run. And what we want to do is we want to change this right now. I want to show you how you can do that. So let's write an integration test. So just to come back from the example before, we already know where the configuration goes to, and now we want to put an integration test into our test suite. What a test suite could look like, that's a manifest. And I just took some silly examples. I execute class foo, a class bar, provide some parameters, and require it to be executed after foo is done, and so on and so forth. So again, the default name in that this is a convention. It's a framework which is very much convention based. So this one here is the name of my test suite. This is where you have to put your test into this directory. Okay, so what you do here is you create your environment that you want to test in. You specify all the parameters that you then want to see if they really make it to your environment. Okay, I want to continue with a short primer on server spec and RSpec because those are the frameworks which I like to use, which you probably use when you want to test your expectations or when you want to express your expectations in that framework. So RSpec is actually a test-driven development tool for Ruby developers, and what this means is Any Ruby developers or any people with Ruby experience? Okay, it's quite understandable, I think, though. So you require class foo here. This is your implementation. And then you describe your test, your assumptions. And you say before any test is executed, any of those coming below here, you want to have fresh instantiation of the class foo, right? And then you want to run the test upon that object. So method bar does something useful. Would be a test case, and you could say my property foo, which is the object of instantiated by class foo, should equal something useful, right? Silly example, but you get the sense out of it. Now, how could we turn that into infrastructure testing? So server spec is an RSpec framework for infrastructure tests. And what you have to do is to require server spec in a file, which you also put in your test suite. And you would say, describe user with the name foo should exist and should belong to group foo. In server spec, you say that the user in this example would be a resource, and this one here would be a matcher. And there are lots of resources and resource matchers supported by server spec. You can also test network setups, you can test if MySQL settings and lots of stuff. You could also describe a file. For example, a certain file, an opbar should be a directory, should have a certain mode, should be owned by a particular user, and should be grouped into a particular group. But then you could also describe a service, and you say the service should be enabled, and it should be running. So this makes sure that when you restart your box, service comes up again. And this is also very interesting when you describe, when you implement services, backends, REST APIs, whatever. You describe that port 8080 should be listening to your requests. And it's very concise, right? You can just take those examples and put it into your test suite. And then, if something is not important, but you could do it on the command line, you could just say, describe command Apache CTL-M should contain proxy_module module to make sure that Apache has the right modules loaded. Now, in order to write the test, just copy one of those examples that I gave. Or take a look at the Puppet module which I implemented, which has a quite exhaustive suite of test cases, which goes a bit further than what I've presented so far. So again, you have your test suite here, and this is another convention. If your test suite contains a directory called server spec, Test Kitchen will say, okay, he wants me to use server spec. So we'll install the server spec gem inside the virtual machine that you were testing, so you don't need to care about any installation. The same applies to all the other test runners like BATS and RSpec, okay? And another convention is that the spec has to be named like the suite and then underscore spec.rb. So this makes it clear that this is a specification. Okay, so this could be an example in your application, very simple one. If you think about the cycle that I mentioned before, the red, green, blue cycle, you would implement your user, make sure that it's present, and then reiterate the cycle and maybe start with a directory that should exist, or an entry in a config file that should exist. Okay, now how do we run it? Now we know how to list all our instances that we could test. What you could do is run kitchen test with the name of an instance on the command line. But it's a bit smarter than that because it actually allows you to provide a regular expression. You could say, test all my test suites on all Ubuntu machines, or just run everything, right? And tell me when you're finished. So the flow of Test Kitchen is as follows. So first you converge the infrastructure. You converge your environment. It means Puppet is run and runs a manifest, okay? And then the environment is set up for testing. That means all the requirements that you need for running server spec, for example, are in place. So that means that the instance is set up, and then the instance is verified. And this is what means a test in Test Kitchen. You could also call these in isolation. For example, when I do an implementation, right, and I figure out, oh, my tests are not working, okay, then I first converge my instance, and then I need to probably make a change in my test suite, and then I just run verify again on the command line, kitchen verify, until the error is fixed. I don't always need to do the full pipeline. That's quite convenient. And when you run a test, this is what you'll see. You see a lot of output. You see the manifest being executed, any output messages, verbose messages or debug messages, and then in the end, hopefully, you'll see that your user foo should exist is true, right? So green means it's accepted, it's there. And it will tell you the number of tests which have succeeded and the number of tests which have failed. And that's all you need to know. And if you do a kitchen list again, when you run kitchen tests, it will tell you that your instance is verified. And if you run kitchen test, it will do one after the other until all are verified, or the first one breaks. I'd like to give a couple of advanced tips which might be useful for you, which go a little bit beyond the basic topics which I just mentioned. Using Test Kitchen with Puppet. What about EC2 deployments, right? You often use an Amazon Linux and not an Ubuntu or a Reddit-based instance in Amazon. How would this work out? So as I mentioned before, there is a particular driver for it which needs to be configured. But if you change my example to this one and provide the correct environment variables on your system before you run Test Kitchen, it will run your deployments on AWS against an AWS instance. And if you're about to lift and shift your application into the cloud, then this is what you should test. Does it work on Amazon Linux? Alright, what about testing REST APIs? This is an increasingly important topic, especially in terms of microservices, right? So this is also an integration test, or even more so, an acceptance test. And unfortunately, this is not supported by ServerSpec. And there is another framework called InfraSpec, which is very interesting, which allows you to test against your processes like MySQL, databases, and lots of other stuff, which is very interesting. It's not yet integrated into Test Kitchen, but maybe someone of you wants to do it. Is someone of you using Infra, or ever heard of it before? No? Okay. It's fairly new. So what you would do is you use RSpec, so it is the language which is underneath ServerSpec. So this is plain Ruby, okay? So what you do here is, and this is probably a bit confusing, but I mentioned this here in the presentation for you. You tell the framework that you want to use RSpec, but since you can also embed RSpec in the ServerSpec environment, so there is no need to create an extra file or an extra test suite. You can just define your test suite in ServerSpec and add some Ruby code in RSpec. Okay? So here we test against the server REST API. We provide basic auth. We accept JSON output from our REST call, and then we make sure that the response code is a 200. And when we parse the response body, we want to make sure that the contents are the ones that we expect. And of course, the counterpart, where you put information into your service through the REST API. This is what you would do in your test case in the manifest, which we looked at before, into the init.pp. Okay. Good. If you would like to see more examples, on GitHub we have the Dynatrace Puppet repository, and you want to look at test integration and the two kitchen files. The reason why we have a different kitchen file so the default solution for us uses Docker. We also have a file that uses Vagrant, reason being that we're also looking into Windows deployments with Puppet. And of course you cannot run Windows inside Docker, that's why we resort back to Vagrant for those use cases.
Well, you can, as of 2 weeks ago.
Really? Wow. You can run Windows on a Docker.
Or you can
The other way
run
around.
Docker on Windows.
Yeah, exactly. But what I want to do is I want to test whether our applications can be automated onto Windows machines. And this use case does not exist in Docker yet, unfortunately.
There is a project for it, but I don't think it's called Docker. It looks a lot like it, and it's related to it, but it's different.
Okay. Interesting. Thank you. All right, now shoot me down with your questions, please.
Yes. There's two ways you can approach integration of kitchen test. You could do, say you're a company that has lots of public modules. What you could do is have one suite defined that has all, like one kitchen setup that has all of your modules. Or you could use a kitchen configuration for every individual module. That's the two ways to configure. Which would you recommend?
Oh, I think that really depends on your needs. I mean, if you say that a module is self-contained, right, and you want to make sure that when a module hits your version control system or gets committed, you want all the tests to accompany your implementations, then I think it makes sense to have the test specific to your module and not cross-module, probably, because this leads you in a situation where you may end up that you have to change your test suite because a certain module changes, but probably not the one that you host the kitchen file in. So I would probably, unless there's a better reason to do so, host the kitchen YAML file and your test suites with your module. Next question. Does it answer the question?
Yeah.
Okay.
It's funny because I was of the same thing.
Okay,
It's
super.
good to hear.
Yeah, good.
I wonder if you've had any luck with running multiple vagrants at the same time, because we've got our end target platform, maybe Amazon. We've got our test integration platform, which might be OpenStack locally. But, we're all developers now. We used to be dev guys, ops guys, but now we're all developers. So, like developers, we like to have something on our own local workstation. And vagrant, fantastic. But I've not had success yet in running more than one vagrant. Whereas I might have an infrastructure that's got 12 different servers.
Yeah.
And I can easily do that in Amazon or OpenStack, but no.
That is a very good point. So Test Kitchen was designed to not test your entire environments, but to test one part in isolation. Okay? So one machine after the other. But there are people trying to find out ways how Test Kitchen could be improved to spin up dozens of instances, no matter where they are, right? It doesn't need to be vagrant. Probably they're going to start small and say, we'll test your infrastructure in a couple of vagrant instances, and we'll have the tests executed on machine 1, and other tests executed on machine 2, and so on and so forth. They're working on it because they see that this is a limiting factor.
Yeah.
And there are some interesting blog posts, if you Google for it, but I've never tried them so far. Because for me, currently, this was enough. But if, of course, if you have a big application,
Yeah.
which spans a couple of instances and Docker hosts and Docker containers, then of course, it makes sense to do that. But I don't know what the status in Test Kitchen and the plans and the roadmap are. But there is a long list of plus ones in the issues regarding that topic.
Yeah.
Yeah. Any other questions? How did you like the topic?
Great.
Yeah.
Very interesting. Yeah.
Super.
Very, very topical. Exactly what I'm working on at the moment.
Yeah, I think the timing is right for those kind of things. And I heard you Dutch people are very direct and very critic. So this is very good feedback for me. All right, so thank you very much.